Platooning, self-driving trucks, they're things that people have been talking about for a long time. Well, Locomation has a new approach to it. Which one of you want to kind of give us an overview of how you're looking at trucking and bringing automation to trucking in a very evolutionary way, I guess you'd say? Who wants to start?
So when we look at the landscape in the automation and trucking and their intersection, there has been a lot of movement in the past couple of years. The trucking industry obviously is looking for some innovation, some disruption to improve their operations and improve their efficiencies, whereas the automation industry is trying to build autonomous trucks, autonomous vehicles that can actually be used on the roads. We personally come from a background of developing autonomous systems for really challenging environments for a really, really long time. So we understand, we spent about a decade at Carnegie Mellon's Robotics Institute building such systems. So we really understand how hard the problem of making a truck fully autonomous is. At the same time, we also understand how hard it is to operate trucking as it is today. So we've been looking for a really nice intersection of how can we make trucking gradually move towards a much more safer, much more efficient future with the proper and staged deployment of autonomy. That's how Locomation was born. Eventually, of course, the levels of automation will be very high. Maybe parts of the entire freight movement is going to be completely automated, but that will have to be an evolution, not a revolution. It's not going to happen overnight for a multitude of reasons. The technical reasons are this is a very complicated problem. Demonstrating autonomy has become really democratized over the past decade or so. A lot of people can, with a little bit of funding or a little bit of resources, can actually demonstrate the underpinnings of self-driving. But there's a huge gap in terms of reliability and robustness that has to be overcome for a demonstration to become a product. So we are being very cognizant about that fact, and we are trying to scope the autonomy properly so that we can have a product as soon as possible with the right amount of autonomy in it as a starting point, and then keep validating, keep advancing the technology further and increase the autonomy level as we go. For that matter, we decided to start with autonomous convoying, where we bundle two trucks together, keep a human driver in the front truck as the leader and as the human shield against the environment, and make the second truck fully autonomous. So essentially we are doubling the effectiveness of a human driver, not replacing them, not eliminating them, but making them more productive and making the driving task more comfortable and the overall traffic situation more safe. And that's our starting point. We dubbed our first product Autonomous Relay Convoy, or ARC for short. How it works is you have two trucks and you have two drivers in two trucks. The drivers manually drive the trucks from the depots onto the highways. And once they're on the highway, there's a big green button you can imagine. You press the big green button to engage our system, and once our system is engaged, the driver in the front truck remains in control. In fact, assumes the control of the convoy. And the driver in the second truck leaves the driver's seat and goes and rests. So at that point, the second truck is a fully autonomous level 4 truck with a very scoped down responsibility. It only has one task, knowing where the lead truck is and just being able to follow that truck. They go like that for a couple of hours or a couple of 100 miles, and then the trucks basically swap places, so two drivers can take turns being the lead driver. This way, we can basically take two trucks to twice the distance, twice as fast as what it will take normally. And what it means for especially the trucking fleets today is an average 30% improvement in their operation expenses. And in an industry where 3 to 5% profit margins are the norm, this is the magical 10x improvement and a game changer technology.
So from a safety perspective, do the rules allow for the driver to be in the seat resting? Does that count as rest?
Yes. Today there's a practice in the industry called team driving. So when there's a time urgency in a delivery, what the norm is in the industry is that they send one truck with two drivers in it. And while one driver is driving, the second driver rests in the sleeper berth in the same truck. From that point of view, what we are doing can be seen as an extension to team driving. So instead of two drivers taking turns driving one truck, now two drivers are taking turns driving two trucks at a time. So the underpinnings of that mode of operation is already there.
And I suppose you get a little bit of efficiency from the platooning aspect too. Is that a big factor?
It's a nice icing on the cake. There's considerable fuel savings due to the reduced air drag around the convoy. The projected savings are around 8% per truck, and that of course adds up, but by itself is not enough to move the needle. The big bulk comes from the improved asset utilization and improved labor efficiency.
That makes sense. And so, Taken, why don't you tell us a little bit about the technology?
Sure. I guess our CEO and my brother touched on certain parts of that technology, the details of the technology. Essentially, as we said, the vehicles are configured from a hardware and software perspective to be full level 4 capable autonomous vehicles, but their operational design domain is extremely narrow at the moment. So in our particular convoy configuration, we have our software system running at all times, actively controlling the follow vehicle, but also providing ADAS kind of capability, even more advanced ADAS capabilities to the lead driver as well, to increase that person's situational awareness. In our application, we are using the human driver in the lead vehicle as a cognitive filter, if you will, because if you look at that from an AI sophistication perspective, actual driverless cars require what is called artificial general intelligence, which is an unsolved research problem for the past 70 years or so. It requires common sense reasoning. It does not only require like really good perception, as many people are focusing on at the moment with deep learning techniques and all that stuff. That is only one piece of the puzzle, but you also have to actually have human level, if not exceeding human level, cognitive capabilities to be able to handle driving tasks altogether. So what we are doing is we are essentially combining strengths of humans and machines. So humans provide that cognitive filter. They are really good at looking at objects, looking at scenes, understanding them, assigning semantic labels to individual parts of those scenes. And machines are good at actually doing very low-level controls and servoing, very, very precise control of platforms. So that's how we are actually bundling the two parts together. The human provides cognitive filter, the robot in the back provides very precise following of that lead. So this is essentially how our technology works. Our sensor configuration is essentially pretty much the same as whatever you are seeing in other autonomous vehicle prototypes. We are making use of 3 different sensing modalities, lidars, cameras, and radars, and fusing them as needed to complement each other's strengths and weaknesses, I should say. And since autonomous platooning is our entry point to autonomous vehicle development continuous spectrum, we wanted to make sure that our hardware is also future compatible. So we designed our hardware and configured our hardware with that kind of expansion in mind. So over time, as we expand the operational design domain of the follower vehicle, the same set of sensors and the same set of configurations will actually help us move towards higher levels of autonomy.
Well, another cool thing was that it's very modular, right? You just replace side view mirrors, for instance, right?
Right. At the moment, our patented sensor configuration actually combines all the sensors around the existing mirror structures. We are not really drilling any holes on the cab of the vehicle. That makes it, as you said, very modular, so we can actually place that mirror pod, just plug it out from one particular truck model, plug it into another truck model, and have it operate. Of course, we have our competing unit and such, but the entire system is, in that sense, very, very modular and very easy to install. Moving forward, the goal we have in mind is to be able to turn this into an almost like regular maintenance kind of operation, because manually driven trucks also require that kind of maintenance, which is handled over weekend usually. So they go into the garage. In our case, it will be they go into the garage fully manual and then come out of the garage over the weekend with self-driving capabilities with our modular.
Out of the cocoon as
with our very modular sensing and computing system, just retrofitted very, very quickly and very efficiently. So that's our goal moving forward.
And so, from a business model perspective, do you see selling to fleets, to independent contractor type truckers, or what do you see the business model?
Our near-term go-to-market strategy starts with very large fleets. And there are a couple of reasons for that. Large fleets usually have their own density in operations so that they can actually benefit from this convoying business. Because for convoying to be really efficient, you need to have a certain density in your operating lanes so that you can actually mix and match two trucks together to convoy. Starting from there, once we have enough of our systems on the road, all individually siloed into the respective fleets, we will start looking into how can we get these two fleets to coordinate, and how can we actually make the technology enabled to smaller fleets and all the way down to owner-operators one day. But it's going to be, again, a progression. Over the next 2-3 years, our focus will be on the large fleets, usually several hundred trucks and up, and work our way down from there.
And you had some pretty incredible numbers. Even just with 5,000 trucks, you'd have an amazing number of miles driven, right?
Right. We anticipate that. So there are about 4 million total semi-trucks in the United States, and about just over 1 million of them usually operate on the highways, or on the long-haul segments. These are the sleeper cabs with the longer back. And we believe, according to our rigorous analysis, we believe our obtainable market is around 200 or 250,000 trucks in the next several years, rather short, while we're still just focusing on the long-haul elements. And even when we just start scratching the surface of that obtainable market, just at 5,000-6,000 trucks on the roads, the real-world exposure our trucks, our experimental autonomy system on the lead truck will start to get is going to be millions and millions of miles per every day. So which will mean that we will basically be getting the same amount of real-world exposure in a day that most of our big competitors, I'm not going to name any names, were able to get in the past decade.
That's incredible. And so from a business model perspective, do you see selling this and then some kind of license agreement or something?
So this is going to be a subscription model. We are going to make autonomy enabled as a service over a period of time. The number we are entertaining right now is about 3 years. So we are going to put our hardware on a customer truck, and they will use it for 3 years, and they will pay us monthly. This helps them managing their cash flow, because the moment they start using the system, they will start seeing the savings. And out of those savings, they'll pay us a healthy amount, if you will. So it's going to work for them, it's going to work for us, and the 3 year is also another magical number. So one of the biggest benefits of this system is the improved asset utilization. The equipment utilization on average today is around 30%, or 7.5 hours a day. And with the proper implementation of this system, we believe we can basically push it all the way up to 90%. So you can
90.
90. So you can basically operate about 22 hours a day, except for refueling, except for pre-trip and post-trip maintenance and inspections. What that will mean is the trucks will be actually, the fleets will be churning through the trucks much faster. Today, the industry average is 5.5 years to replace a truck. But with our system, we anticipate that actually they will basically churn through a truck in 3 years. Hence our 3-year-long subscription model.
That makes sense. And so you guys have done some pretty amazing things in a very short time. Why don't you tell us about your trucks?
Sure. So even though on paper Locomation has been around for a while, our actual action started close to the end of 2018. So when the 5 co-founders kind of left Carnegie Mellon's Robotics Institute to focus fully on this venture. And then we started recruiting other engineers and such. Of course, you cannot handle everything. Built 2 trucks by 5 people, so we needed additional hands. And that kind of ramp up, I guess, mostly materialized around March or so. We had 12 or so people by then. We purchased our trucks and started retrofitting them. And as of November, last November actually, we successfully completed our fully autonomous convoy test. So between March and November, however many months that makes, we were able to build 2 iterations of 2 trucks from scratch with under 20 people and very limited $5 million or so of seed funding, which is a public piece of information. and it's 7-8 months of duration. So in that sense, it's kind of a superhuman effort, but our team is incredible, and every single member of our team, even though we are a small one, is a superhuman person. So once we get enough fuel in our next funding round, hopefully we will be able to move even faster and scale our operations.
Just a small fun fact. Right now, in our engineering team, the average robotics and autonomous vehicle experience per engineer is about 14 years.
That's incredible, given what a young field it is. Yeah.
Right. So it's probably the most experienced Tiger team the industry has ever seen, and that basically reflects on our performance so far.
Yeah, and it sounds like there's not just theory; you have a lot of practical knowledge too.
Yeah, all the way from the basic science, the first principle fundamentals of everything, all the way down to quite literally nuts and bolts of how to put together such an incredibly complex system together.
So when do you think we can see this on the road in a production form?
Oh, that's a great question. Maybe you should...
Production form, I'll answer, the rest you answer. We are determined to get the very first commercial units out of the door around mid to late 2021.
Okay.
It's not going to be thousands out of the gate, but we will have some form of commercial. Yes, the very first generation, a handful of units, maybe several dozens of units, sometime in 2021.
So maybe I can answer it from a technical perspective. We are actually taking safety very seriously. We just don't want to rush into putting our systems on public roads and jeopardize people's lives. We don't want to be reckless. This is a dangerous and very serious business, and we are taking it so. Having said that, we are in the process of applying for the required permits in different states, essentially, that we are planning to operate. Unfortunately, there is no single umbrella, like federal thing that you can go and get your permits from. So you have to do it state by state, and we are in the process of submitting our applications and getting our approvals, while we are continuing our closed track tests in a very rigorous manner. It doesn't mean that we are not collecting any data, but we are definitely not operating autonomously. We are taking our vehicles out to public roads every once in a while in manual driving mode to just collect some data and start consuming that data in the background. But in the upcoming few months, we should be actually getting on public roads with autonomy mode on once we get the green light and thumbs up from the government bodies regulating this. Yeah.
Yeah, you have a operational domain that really is probably more of a federal domain, should be, right, in one sense.
Ideally, but today it's mostly a patchwork. Yeah. The good thing, though, is, of course, a single point of entry would have been much nicer, but everybody across the board is very, very cooperative. So everybody really would like to enable this technology. It's just most of the times people don't know how, what to look for, what it means to be safe, what it means to be not reckless, etc. So there is a lot of collective effort going on into that, educating and figuring out from the regulation point of view, the sensitive points, what we as the technology providers should be paying attention to, etc. So there's a co-education going on at the same time as well. But overall, the momentum in the regulatory landscape is enormous. Just in the last year or two, more states have passed legislation for platooning and full self-driving operations than the previous decade combined. So we really see a hockey stick in the regulatory landscape. Still figuring out the details of the bureaucracy and the paperwork, etc. Everything takes time.
Well, and while we're on the topic of federal rules, you use V2V communications, dedicated short range, and V2CX. And so what are the implications of the FCC's proposed rule change from your perspective? Is there any impact, or what are your thoughts on that? And this is the reallocating 45 megahertz to Wi-Fi and leaving 30 megahertz for the other.
We are very, very closely following the discussions there. We are basically the very end users of DSRC. In fact, we are not relying on DSRC as the communication protocol. It's just another radio transmission protocol medium for us. So we don't anticipate any hurdle or any blockage on our end, and especially because we are using DSRC, again, just like your regular Wi-Fi, as a peer-to-peer, point-to-point communication link between two trucks that are traveling very close together. So the implications, especially in the near future for our operations, will be minimal. Having said that, we are constantly on the look for the alternatives and what's coming up. 5G is anything going to happen in a reliable way. So getting 5G in the middle of Manhattan is one thing, getting 5G in the middle of nowhere in Arizona is another thing. And for us, the second part is more important. And that was the original reason why we decided to go with DSRC, so that we can actually operate in a reliable manner.
And you mentioned that you wrap your message in a proprietary encryption type thing, right?
Right. Yeah, I mean, of course, at the end of the day, those things will be two entry points, wireless entry points, if you will, traveling, and any kind of people with bad intentions may try to hack into those systems, and that's a common and general concern when it comes to autonomous vehicles. Actually, we've seen some examples in the past, not necessarily in the autonomous vehicle domain, but some really, really bad intentioned people hacking into, I don't know, certain brands of vehicles and taking control and causing accidents. So we don't want that kind of thing to happen, especially when it comes to trucks, like 40-ton trucks traveling at 7 miles an hour, etc. That's why we want to make sure that whatever data packages we are essentially exchanging between the vehicles are encrypted and go through several kind of checks, whether these packages are really coming from my peer or not, before we act on them. So that's why we are doing that kind of additional packaging on top of the existing basic safety messages.
And you mentioned that you actually have redundancy in the sense that each rear view mirror has its own set of sensors and so forth, right?
Right, yeah. So that provides redundancy from multiple perspectives. There's hardware redundancy as well as modality redundancy. As I said at the beginning, we are making use of 3 different modalities when it comes to sensing, and there's also the wireless communication aspect of it. And having both of those units on either side of the vehicle provides, and having the fact that we are dealing with really long vehicles with maybe a metal box in the back that could cause certain interference and such, we just want to make sure that the configuration we picked would be flexible enough to enable, at least on one side of the vehicle, a line of sight communication between the 2 vehicles. And also from an operational perspective, that kind of double configuration provides a graceful degradation. We don't want to have any kind of single points of failure in our system, so that's why we duplicated the sensing suite, if you will. So if a subset of those sensors go down, we still have other sensors to operate with while taking additional actions towards how to mitigate that particular kind of degradation. So that was the main design decision behind that particular configuration, essentially.
Well, excellent. Well, I really appreciate your time and the thoughtfulness and safety that you're looking at in this project. So thank you
very
again.
much. Thank you. Appreciate it.